Today in class, we talked about multiplying using partial products. So you guys are probably used to learning how to do the traditional algorithm or traditional method of multiplying, which is great. It works, and that's how I learned it as well. However, as I've taught math the past couple years, I've discovered that I really don't know as much about math as what I thought I did. And a lot of that is because we weren't taught the whys behind it. We were just taught, hey, here, do this method. It'll work. It'll get you the answer. So part of my goal is obviously for the kids to not only be able to perform the operations, but to also have a deeper understanding of what they're actually doing. So partial products is a way to get to that understanding. Today we learned the box method, and it's basically just a way that we're setting it up. Partial products means that you're not getting the full product at the beginning, you're just getting parts of the final product, and then you're going to add them all the partial products together to get the large final number. So for example, if we have 52 times 34, we're going to take these numbers and we're going to split them into expanded form. So writing an expanded form is just breaking the number down to what it actually is. So I have 2 1s and I have 5 10s, and 5 10s is actually 50. So we would do 50 plus 2, and then for this number we're going to write it down on the side, and that's going to be 30 plus 4. Again, I'm just breaking it down into expanded form. So then I'm going to draw my box, and my box will be on the inside of these 2 expanded forms. And I'm just, anywhere there's a plus sign, I'm going to draw a line. So since I have 2 plus signs, I have 2 lines. And then from there, we're just going to multiply. So we're going to multiply 30 by 50. So 30 times 50. And when we multiply 30 times 50, we get 1,500. Then we're going to do 50 times 4. And when we multiply 50 times 4, we get 200. And then we do 30 times 2. And when we multiply 30 times 2, we get 60. And then finally we have 4 times 2, which is 8. So all of these numbers in red would be considered our partial products. And then our final last step is to add all these partial products together. So we'd have 1,500 plus 200 plus 60 plus 8. And realistically, we should kind of get an upside down triangle as we're lining these up to add. So when we add these all together, we get 1,768 as our final total. Now, this is a little bit of a drawn-out method. However, as the kids showed me using traditional, when I asked them what that placeholder actually does, they couldn't answer it. They just told me, well, I've just been told to put a 0 there. They don't understand the meaning of that placeholder, and if we're being honest, I probably didn't either when I was their age, because I was never told that either. And maybe some of you are probably thinking to yourself right now, well, I don't know what that number is either. Why do I put that 0 there? I've never been told. So it's not simply a placeholder, it's a 0 because you're multiplying by tens, not single digits. So that's why I like partial products, because I think they have they develop a deeper understanding of what they're actually multiplying together. We're going to do one more example, and this time we're going to do a 3-digit times a 2-digit, and that way you can kind of see that it's the same method, whether it's big numbers you're multiplying together or small numbers, it's the same concept. So we're going to do 132 times 53. So again, I'm going to start by writing my number in expanded form. So I have 100 plus 30 plus 2. And my other number then is 50 plus 3. So this time when I'm drawing my box, I'm going to have those divider lines, again, wherever the plus sign is. So I'm going to have an extra line then. And it doesn't have to be perfect, because really, honestly, for these single digits, we don't need that much room. So they don't have to be evenly marked. I know the kids tend to worry about how neat their boxes are, but that's what's great about this, is that you're really just, it's not as confusing as lattice, which I'm sure some of you have seen your students use. So we're going to start by doing 50 times 100. And when we do that, we get 5,000. And then we do 30 times 50. And then again, we get 1,500. And 50 times 2 gives us 100. And the students all learned yesterday how to multiply numbers, big numbers ending in 0. So they're pretty fluent in that skill. They did really well with that. So to them, these big numbers really aren't that difficult. 100 times 3 equals 300. 30 times 3 is 90. And then 2 times 3, or 3 times 2, is 6. I try to tell the kids that, again, that it doesn't matter what order they multiply these in. We could say 100 times 50. We would still get the same answer. So making sure your student understands that, that property of multiplication. Finally, we just need to add all these numbers up. You can, if it's easier, we can just add these 3 numbers together and then these 3 numbers together and then do one final answer, or you can add all 6 together. So just to kind of break it down, I'm going to add the 3 together separately. So my first for this total is 6,600, and then I got to add these 3 together. So I'll do that on here. So 300 plus 90 plus 6 is 396. And then finally I add that to this total. So I get 6,996. And again, we could check that using the traditional method. But I think the kids will have a deeper understanding of really what's going on and what concepts they are doing here. As always, if you have any questions, feel free to let me know. And hopefully we can build on this place value multiplication concept.